So let us start with the first law of thermodynamics. The first law of thermodynamics states that the energy can neither be created nor be destroyed. Energy can only be transferred or changed from one form to the another. This law is also known as law of conservation as it talks about conservation of energy. It says that energy is only conserved and it is transferred from one form to another. It cannot be created randomly. It cannot be created. It just changes its form. So we can also put this as delta E is equal to Q plus W, where we can say that delta E is change in the internal energy of the system that is under study. In another video, I have discussed the types of systems. So you can go to that video and check what are the types of systems. There is open system, there is closed system, there is isolated system. So here delta E, that is internal energy of the system, is given by sum of Q, that is heat, plus sum of W, that is work done on the system. So this is a way of expressing first law of thermodynamics, because it is any change in the internal energy, that is delta E of any system. Delta E of any system is given by sum of Q, that is heat that flows across its boundaries, and work, that is W, the work done on the system by the surrounding. So this is the first law of thermodynamics. It is also known as law of conservation of energy. If we are talking about biochemistry, let us take an example, very simple example of plants. Let us take an example of plants, that there is sunlight. So how these plants are able to survive, from where do they get this energy? So they are getting the energy in the form of food. So how are they creating this food? They're converting the sunlight, a form of energy that is present in the form of sunlight. They are converting it into the organic matter, and that is how they are going to survive. So that is one of the example that we can take to study first law of thermodynamics. We can think about n number of examples. If you think that you have switched on a light, you might think that it is producing light, but when you switch on the lights switch, then electrical energy is converted into light. Some form of energy is always converted to some other form of energy. So we can say that the first law of thermodynamics is applied, it can be applied everywhere in the nature. It is universal. So now we will discuss about second law of thermodynamics. So the second law of thermodynamics states that entropy of any isolated system always increases. So to understand this statement, or to understand this law, we need to first understand what is entropy. Entropy, in simple words, can be put as randomness. So the law states that entropy of the isolated system always increases, or it can be simply put as the entropy of the universe, which is the ultimate isolated system, only increases and it never decreases. So When we are understanding this law, we need to understand it in a very clear manner that here we are not only talking about the system, we are talking about the universe together. The randomness of the universe always increases. So, if we are taking into consideration a particular system, the particular system may have negative delta S. What is delta S? Delta S is change in the entropy of that particular system. So delta S for any system can be negative, but when we are talking about the universe together, it always is going to be positive. So let us see how to put it in an equation. So here we can see that the overall delta S of the universe, this is the delta S of the universe, it is always going to be positive. So delta S of any system can be negative. That means any system can go towards orderliness, but the delta S of the universe will always be negative. So let us take an example of biochemistry here again. We say that cell is going to grow into an ordered manner. It is always going to become ordered. So we can say that delta S of the cell is negative, but when we are talking about the total universe, then it always increases. The randomness of the universe always increases. So these two laws are very important when we are talking about biochemistry, and these are universal laws. They are applicable to each and everything. So this was the second law of thermodynamics, which says that the overall entropy of the universe always increases.